Hello everyone. So now we will solve these three circuits. So in these circuits, L1 is having initial current of I naught. In all these three circuits, L1 is initially having I naught current and L2 is having zero current. The current in L1 is IL1, the current in L2 is IL2, and the current in resistance is IR. The switch is being closed at t equals to 0. You have to draw the current waveform. Voltage waveform we can also see, but I guess you can write it on your own, because if you know the current, voltage would be V equals to L di by dt. So simply the integration into the inductance. That's it. Okay. So we will solve the circuit first by Laplace, and then we will see what is actually happening in the circuit. Okay. So this switch is being closed at t equals to 0. So first we will solve by Laplace. Okay. So how will we make the Laplace equivalent? L1 and L2 will be replaced with its impedance. So L1 will be replaced with L1s, L2 will be replaced with L2s. And what will happen to current source? The current source we can make a current source to a battery. How will we make the battery? In the direction of current minus to plus. In the direction of current minus to plus. Minus to plus. In the direction of current, that is Li naught. Okay. This is L1s. And this is L2s. This is the equivalent circuit, right? And now this current is flowing in this direction. One current is flowing in this direction, that is IL1s. Okay. So Li naught is IL1s to L1s plus L2s. Here one thing we know, that this is IL1s and this is IL2s. So IL1 we can write in small. IL1t is negative of IL2t, right? Or IL2t is negative of IL1t, because this is IL1 and this is IL2. So both are negative of each other. So from here we can get the value of Li1, that is Li naught L1 I naught, sorry, this is L1 I naught, L1 I naught, this is L1 I naught, because in the direction of current minus 2 plus L1 I naught upon L1 plus L2 into S. So what is IL1t? That is L1 upon L1 plus L2 I naught into UT. So this is what is happening with IL1, and IL2 will be simply the negative. So what is happening with IL1? IL1 is going from I naught to, it is going from I naught to Li1 upon L1 plus L2, right? This is the graph for Li1. Sorry, IL1, not Li1, IL1. So it is going from I naught to this value, I naught to some other value. I naught to this some value. And what about IL2? It is going from 0 to negative value, right? Because actually IL2 is flowing in this direction, but we are making in this direction. Okay, as per the sign, this IL2 is given like this, but actually the current is flowing in this direction, right? So that's why we have to make it negative, like this to well and good, fine. So this was Laplace transform, but that would not be helpful for the interviews. It is good for written test, right, or gate exam, but In the interviews, what will you do? So that's the main concern here. So let's just talk about method 2. So what is happening in the circuit? The inductor L1 will say I will have I naught current. The inductor L1 will say I will have I naught current, and the inductor L2 will say I will have zero current. Right? Because L1 was initially having I naught current and L2 was initially having zero current. Right? So this will say I naught, this will say zero. But both are connected in series. Just as you close the switch, both will be connected in series. Now this is saying I naught current, this is saying zero. It can't happen, right? What you will do, you will just make it like this. This is saying I naught and this is saying zero, so it is open circuited. So is it possible? No, because KCL is being invalid here. I naught current is flowing here, so how can zero current flow here? It has to be some value, right? So both have to adjust, right? One is saying I naught, one is saying zero, but it's not possible. Both have to adjust. So how will they adjust? Flux conservation, right? So what I will say, at t equals to 0. So the inductor doesn't allow instantaneous change in the current, but here it will change. So this is L1, this is L2, this is saying I naught, and this is saying 0 ampere. KCL invalid. So what will happen? Flux conservation. What is the initial flux? That is L1 I naught. What will be the final flux? L1 plus L2. Now for final flux, what we will do, like, the thing is that both of them should have the current, but in the same direction, right? If I am saying this is having IL1 current and this is having IL2 current, okay, but the direction of both of the current is different, right? Are you getting my point? IL1 is negative of IL2, but if I am applying the flux conservation, both of them should have the same direction. So the current would, in IL2 the current should flow like this only. Same direction as in the same direction of I naught. Like initial flux was in this direction from up to down. I naught was there. So L1 I naught. So direction we are taking is from up to down. So in the complete circuit, there is one inductance now, and that is L1 plus L2. Right? There is one inductance now, that is L1 plus L2, and this is a closed circuit. So we will expect that there will be this current IL that would be flowing in this inductance. Like I naught was flowing in this direction, so IL should also flow in this direction, right? So your IL would be L1 I naught upon L1 plus L2. Take your time and think about it, what I am saying. Initially, your current was in this direction. So your flux was like this, L1 I naught. Now there is some other current. This IL is, I am not saying this IL is equal to IL1 or IL2. Forget about this. Initially the current was in this direction. Now the current that I am writing, that has to be in this direction as well. Like in case of capacitor, what did I do? This was charged to some V1 voltage, C1, and then this was C2, right? Then when we close the switch, we call that there would be a common voltage CVC. So we made that voltage in the same direction as V1. So now we will make the current in the same direction as I naught. Are you getting my point? So I naught was flowing in this direction, so the final current would be in this direction as well. Now after that, what will happen? That IL is equals to IL1 because it is in the same direction, but it is the negative of IL2, right? Because IL2 is flowing in this direction. IL2 was, as per the given question, IL2 is flowing in this direction, right? IL2 is flowing in this direction. So this IL is negative of IL2. Are you getting my point? So this is IL. So from here basically we get IL1 equals to L1 I naught upon L1 plus L2, and IL2 is equals to minus L1 I naught upon L1 plus L2. Okay, understood? So this is what is happening now. The inductor is instantaneously changing its current. The inductor is instantaneously changing its current, so that there must be an infinite voltage, right? There must be an infinite voltage produced. So how you can write that voltage? Now how you can say that there is an infinite voltage? Look, let's just assume I am writing VL2. So what is the current in VL2? Some I current. Let's assume some I current is flowing. So, and how much resistance VL2 is seeing? Infinity. So how much is the voltage across the VL2? That is infinity. Like, why it is not the same in this case? In simple RL circuit. In simple RL circuit as well, what you will do? You will first open circuit this, right? You will first open circuit it. So why can't we say there is infinite voltage? Because simply this 5 volt is coming here. So you can't say there is infinite voltage. But there is no voltage source. In this problem, there is no voltage source, right? So we have to write the voltage like this: current I into resistance. If current I into resistance, it is seeing infinity. So if VL2 is infinity, VL1 is the same. So VL1 is also infinity. So like that, I can say there is infinite voltage across the inductors. Okay. And if there is some other way, so like this is what I thought. That's how I can explain that there is infinite voltage. We can certainly see there will be infinite voltage because current has to change instantaneously. But this is the way we can explain that there is infinite voltage, because the resistance we are seeing is infinity. And if there is some other way you can think, then you can also tell me in the comment section or on Telegram, anywhere. Okay. So this is the way I thought we can explain that there is infinite voltage. So this was the first circuit. Let's move on to the second one. Okay, I will draw the circuit. So tell me, okay, first we will solve by Laplace as well. So it is like we are solving by Laplace, so it is simple, very simple analysis. Like Laplace transform. Okay, so now you can make a current source as well here, or you can make a voltage source as well. So when I solve the circuit, it seems like that making a current source is much easier here. Okay, so what I will do, like there are two way na. If inductor is having this I naught current, so I can replace it with the battery from -2 plus L I naught LS, and there is one more way that I can make a current source I naught by S, and then a inductor in parallel. So there are two ways. I have explained both of the ways. So basically what I am thinking, I will make a current source and an inductor in parallel. Okay, so the current I naught is flowing in the downward direction. This is I naught by S. And then in parallel we have L1S. Then in parallel we have a resistance R. And then in parallel we have L2S. So tell me, this is IR, right? This is IL2. So tell me, what is IL1? Is this IL1? No, this is not IL1, right? IL1 will be the combination of the initial current plus this current. So this will be your IL1, right? Basically IL1, like there are three currents. IL1 is flowing in this branch, IR is flowing in this branch, IL2 is flowing in this branch. So IR, IL2 in this branch, so IL1 will be here, not in the inductor, this current, inductor plus the initial current. So this is IL1. So first, what should we write? Look, I can write IL2. So what will be my IL2? The current will be divided in inverse proportion of the inductance, right? IL2S, sorry, IL2S, IRS. The current will be divided in the inverse proportion of the impedance, sorry, not the inductance, impedance. So here we have L2S impedance, and this will provide me how much impedance? R L1S upon R plus L1S. Impedance, right? We are talking about the impedance. This is providing me R L1S upon L1 plus L2. R L1S upon R plus L1S. right? So here we are seeing this much of impedance, and here we are seeing L2S impedance. Now this I naught S current will be divided into this. So IL2S would be simple network analysis. This is nothing else. You can apply nodal analysis as well. I am just dividing the current in the inverse proportion of the resistances. So in L2S, how much current will go? This resistance divided by the total resistance plus L2S. Okay, this is your IL2S. Minus RL1S RL1S plus RL2S plus L1 L2S square RL1 upon L1 L2S plus R L1 plus L2, right? Now I can take L1 L2 outside, right? I can take L1 L2 outside. So what will be IL2S? This is simply mathematics. You just need to solve the mathematics. IL2S. So this would be minus RL1 minus RL1 upon L1 L2. So it would be minus R by L2 minus R by L2 S plus R into L1 plus L2 by L1 L2, right? So IL2T would be minus R by L2 e to the power minus L1 plus L2 upon annual L1 L2 into T UT as well. There is something wrong. What did we do? We forgot to multiply I naught S. We forgot to multiply I naught S. So this is what happens in Laplace transform actually. Okay. Now the whole calculation went wrong. Now we have to solve it again. Okay. So I will just write down the final answer. That's why I never prefer Laplace transform, because these kind of things happen. We forgot to multiply I naught S. Are you getting my point? IL2. So I naught S we are dividing, no? Now we forgot to multiply this now. So I will just pause the video and just write down the final answer. Okay. So this is what we got, IL2. Now you can solve similarly for IRS and IL1S using current division, okay, or any other method, whatever you see. So here just simple mathematics is there, right? You are not using your brain, just simple mathematics you are applying. Total resistance you are seeing. Then in case of R2, what you will do, you will make both of them as a equivalent resistance. So equivalent, not resistance, impedance. So equivalent impedance would have been L1 L2 S square plus L1 plus L2 into S. So equivalent impedance would be L1 L2 S upon L1 plus L2. So these two, this one and this one will make this impedance. So now you will divide the current between R and this impedance. So how will you divide? L1 L2 S upon L1 plus L2 divided by L1 L2 S upon L1 plus L2 plus R. So by that you will divide the current. Are you getting my point? And then for IL1 S, you can simply like just take the negative of those both of the current and just add them up. So IL1S is minus IRS plus IL1S. What I am saying, IL1S is minus of IRS plus IL2S. Okay. Now the method 2, the method that we are going to actually use, because in the exam as well, if you solve by Laplace transform, there is high probability that you will do something wrong. Okay, because the calculation is a bit of complex. Although in exam L1, L2 value will be given, so you can apply Laplace transform as well. But since I will be giving you the concept, I don't think you will be going to the Laplace transform. Like very simple concept I will give you. So you can also think what is happening at t equals to 0. At t equals to 0, what is happening? This inductor is initially having I naught current, right? This is the resistance R we are having, and here it is open circuited. This was our IL1. Forget about it. I will just write this is L1, this was R, and this is L2. Now tell me one thing. Now this I naught current has the path, right? In the previous question, this I naught current has to flow through L2. So they have to change the current. Now this I naught current can flow through the resistance, right? Because it has the path now. So it will flow through the resistance and it will generate a voltage of I naught R. Are you getting my point? So at t equals to 0 plus, what is happening? This is an inductor which was initially having I naught current, right? Now the same I naught current is flowing through the resistor and it is giving a drop of I naught R, and the same drop is developed across the L2 resistor, right? So that means because of this drop you are having a current in this direction, and because of this drop you are having a current in this direction. So what is happening? This I naught R drop increasing the current in L2 but in opposite direction of IL2. This is the direction of IL2 and this is the direction of IL1, right? This I naught R voltage drop increasing the current in L2 but in the opposite direction, and this I naught R current decreasing the current in L2 because this drop will be coming here like this and this drop will be coming like this. So it is increasing the current in this direction for L2 and it is increasing the current in this direction for L1. But since initial current I naught is flowing in this direction, so it is reducing the current in L1. Initially we are having I naught current, but eventually the I naught current will reduce because of this I naught R voltage that is applied in the opposite direction. Are you getting my point? This I naught R voltage is applied in this direction. For L2 it is increasing the current in from up to down, and for L1 as well it is increasing the current in up to down, but since I naught is flowing from it's from down to up, it is increasing the current from down to up, but since I naught is flowing from up to down, so I naught will be reducing. So IL1 will be reducing from I naught to some value, and IL2 will be increasing but in negative direction, but in negative direction. Now when will the increase and decrease in the currents will flow? IL1 and IL1 and IL2 will be constant. This is what steady state is, right? Steady state is the current in the inductor should be constant. Will be constant when the drop across them becomes 0. Becomes 0. And when it will happen? When will the drop across them, both of them will become 0? When there is no current in resistance, right? If there is 0 current in resistance, the voltage drop across resistance will be 0 and the same voltage drop will be across the inductance will become 0. IL1 and IL2 will be constant when the drop across them becomes 0, and this will happen when there is no current in resistance. No current in resistance. So what is actually happening? IL1 is decreasing, and minus IL2 is increasing, right? Because the direction I have made is this. But the current is increasing in this direction. At steady state, IL1 will be negative equals to IL2 and IR becomes 0. So both of the current will be equal. So basically, what will be the steady state IL1 and IL2? Steady state IL1 and IL2. So tell me, what will be the steady state value of the current? I naught is decreasing and this one is increasing. So there will be some point where both of the current will be equal, right? This is decreasing, this is increasing. So there will be some point where both of the current will be equal. So what will be that point? By the way, what is the time constant of this circuit? This one, first circuit, time constant is 0, right? Why it is 0? Time constant is L by R. R is infinity. If you see from here, open circuit, like I just want to see what is the equivalent resistance here. What is the equivalent resistance here? L1 plus L2 will be 1. Inductance will be L1 parallel L2, L1 parallel L2, and there will be resistance, infinity resistance. So R equivalent is infinite. So time constant is 0. Also you can see it is being stabilized at initially only. From I0 to suddenly it is Li0 upon L1 plus L2 and it remains there. So the time constant is 0 here. We will discuss the time constant in this case. Okay. So what will be the steady state IL1 and IL2? So Li0 flux conservation we are applying. This is what we did in the capacitor as well. Flux conservation. So Li0 L1 plus L2 IL, where we have to consider IL in the same direction as I0. IL is in the same direction as I0. So what is the direction of I0? I0 is the direction of this. So IL will be flowing in this direction. Now the effect of resistance is gone because there is no current in the resistance. So IL would be equals to IL1, but it would be in the negative equal to IL2. Are you getting my point? IL would be equals to IL1, but would be the negative of IL2. Because the effect of resistance is gone, there is no current in the resistor. So at t goes to infinity, what is actually happening? I will just make the circuit here. At t goes to infinity, there is no current in the resistance. If there is no current in the resistance, I can simply say there is no current going in the resistance. Okay, I'm not saying that it is open circuited. I can just replace it like this. Okay, and this is L1, this is L2. So this is what I am saying, IL1. IL. This is my IL. This is my IL1, and this is my IL2. Right? So where IL is equals to IL1 is equals to minus IL2. So IL is equals to Li0 upon L1 I0 upon L1 plus L2. Okay. So IL1 is, so this is what is happening at steady state actually. This is the condition of steady state. We should write infinity, infinite. it would be L1 I naught upon L1 plus L2, and L2 infinity would be minus L1 I naught upon L1 plus L2. So are you getting my point? What is actually happening? Look, what is happening? Initially the inductor L1 was having I naught current. Now the same current was flowing through the resistance. So because of that, the current in the L2 will increase, but in the negative direction, and the current in L1 will decrease. So it will keep on increasing and decreasing until in both of the in both of the inductance, the current is same. So from I naught to, it will decrease to Li naught upon L1 plus L2, and in this L2 it is decreasing from 0 to minus Li naught upon L1 plus L2. Are you getting my point? And in case of IR, what is happening? Initially it was I naught and eventually it goes to 0. So I will write down for all three. IR at t equals to 0 plus was I naught, and IR at t equals to infinity equals to 0. IL1 at t equals to 0 plus was I naught. IL1 at infinity goes to Li naught upon L1 plus L2. IL2 at t equals to 0 plus was 0, and then it increases but in negative direction. It is increasing but in negative direction, just because I took the sign like that. Okay, what is the time constant? Forget about the initial condition and everything. This is R, L1, L2. What about L equivalent? L effective, I should say. L effective is L1 parallel with L2, right? So L1, L2 upon L1 plus L2. What is R equivalent? That is R only. What is time constant? L by R. Okay, this is the time constant. Now you can write down the equation for IR and everything for IR, going from I naught to 0. IL1 going from, this is the infinity value, and starting from 0. Starting from I naught, actually starting from I naught, right? So if I need to start it from I naught, I have to write. Look, just that formula you need to apply: y of infinity plus y of 0 minus y of infinity. When you solve this value, y of 0 minus y of infinity, you will get this. Okay, how did I write it directly? Because I know at t equals to 0 I need I naught current. So if I put t equals to 0 in this equation, what I will get? L1 plus L2 into I naught upon L1 plus L2. So L1 L2 will get cancelled, I naught only I am getting. So I just thought that what should I write to get I naught at t equals to 0. So this is how I wrote. Are you getting my point? You can simply apply the formula as well, or you can think like, I need at t equals to 0. At t equals to 0, this will be 1. So only this factor and this factor will come. So I need to write this factor such as that at t equals to 0, it becomes I naught. So I wrote it L2 by L2 into I naught upon L1 plus L2. Getting my point? So this is my IL2. This is my IR. Sorry, this was IL1. Now IL2 I will write from 0 to, it will rise to some value, that is this, minus L1 I naught upon L1 plus L2. 1 minus e to the power minus t upon tau ut. Okay, now you can make the graph of all three. Okay, so from what about initially, it was for IR, it was 0, for t less than 0, then it rises up to this value of I naught and then it decreases to 0. I naught and then decreases to 0. Right? What about this IL1? IL1 was initially I naught. Initially it was I naught. Okay. Initially it was I naught. Then decreases to what? L1 I naught upon L1 plus L2. Slowly it decreases. Okay. Now what about IL2? Initially it was 0. Then it increases in the negative direction to minus L I naught upon L1 plus L2. Okay. This is IR, IL1 and IL2. Now you can draw the graph of VL1T, VL2T as well. Like there will be no impulse. Why there will be no impulse? Because the current is not changing instantaneously. Right? So no impulse will be there. So what do you think what will be the expression of VL1 and VL2? Okay, let's just write it. So let's just VL1T plus what will be VL1T? Actually, I need to show in the diagram. So if I show in the diagram, this I am taking VL1, this I am taking VL2, because at all the everywhere. Okay, I will have to make one more diagram. Okay, then this is L2, this is R, this is L1, yeah, this is L2 and this is L1. Okay, let's just call this potential as V. So V is equals to VL1T plus VL2T plus VRT. Okay, so tell me what was the value of VL1 at t equals to 0 plus, not VL1, value of V at t equals to 0 plus. You should be able to tell. It was minus I naught R, right? I naught current was flowing in this direction, so it was minus I naught R. Eventually, what will be the potential? 0, right? Eventually, it is 0. V of infinity is 0. How does the graph? Why it is 0? Because there is no current in the resistance. If there is 0 current in the resistance, how much drop it is giving? 0. And also VL1 and VL2 goes to 0, then only it is steady state. If VL1 and VL2 goes to 0, then only there will be no flow of current, right? Sorry, no further increase in the current. There will be flow of current, but the flow of current will be constant. The current will be constant. The current was L I naught upon L1 plus L2. So the current flow was constant, but the voltage becomes 0. This is the graph of Vt. Okay, you have to, if you are watching my lecture, you have to give complete concentration. Okay, I'm not going to give you here mathematical analysis or anything, because this is what you can find everywhere. But these things that I am delivering here, I don't think you will be finding anywhere in the YouTube or in any courses. So all these analyses are not copied from any book or anything. I myself developed it. Okay, like I just solved the circuit by Laplace, and I thought what should be happening in the circuit. So this is how I have developed it. I'm not copying it from any book or from any lecture. Okay, so if I'm delivering it here, I need you to pay full attention, then only you will be understanding it. It's not that simple mathematics that you first at 1 second you are thinking about India's World Cup scored, and secondly you are thinking about World Cup final, then you are thinking about your job. So these things cannot happen. Actually, I am also thinking about India's World Cup final currently, but yeah, you should be focusing completely uh, in the on the lecture only. Okay, so what was the time constant? Time constant was L1 L2 upon L1 plus L2 by R. Okay, so this is what was happening for voltage. Now let's take the circuit third. So tell me what is happening initially. This inductor is saying I will have I naught current. This inductor is saying I will have zero current. Both are connected in series or parallel. Both are connected in series. This is saying I will have I naught current. This is saying I will have zero current. Can that happen? No. At t equals to 0, here we have I naught current. This is having zero current, but both of them have to adjust to some current. And how will we find that value? By charge conservation. Okay, sorry, flux conservation. So L1 I naught will be equals to L1 plus L2 IL. So IL would be L1 I naught upon L1 plus L2. So basically IL is equals to IL1 at t equals to 0 plus, because IL1 is in this direction and IL2 is in this direction, so it is the negative of minus IL2 at t equals to 0 plus. Okay, so suddenly it is rising up to or going to some other value. Now what is happening later on, that we need to see. So now at t equals to 0 plus, this was at t equals to 0. Did I write t equals to 0 plus? Yeah, t equals to 0. So at t equals to 0 plus, what is happening? This is L1, this is L2, this is resistance R. This is having current L1 I naught upon L1 plus L2, right? Suddenly from I naught to it is decaying to L1 I naught upon L1 upon L1 plus L2. And in this, the current is increasing from 0 to L1, L1 I naught upon L1 plus L2. And the direction of current will be this, right? So now the drop across the voltage resistance will be like this, right? Now the drop across the inductance will be like what? If we had made a resistance L with the current I naught, so how will we make the drop? Like this, right? In the direction of current, minus plus. Voltage drop, V equals to L di by dt, right? L di naught by dt. If the current is flowing in this direction, it is charging the inductance from left to right. So minus plus to minus. Although in Laplace transform we make minus to plus, but there is the reason, right? There is a reasoning behind this, and that reasoning I have already explained, right? Because we make the current source, and if we are going from current source to voltage source, it will be minus to plus. But what is actually happening? If there is I naught current is flowing in this direction, that means it is charging the inductor in this direction from plus to minus, right? If I am giving I naught current, it is charging the inductor, right? So if current is flowing from up to down, that means the voltage drop across it is like this, right? And what about this? If the current is flowing from up to down, that means the voltage drop is like this. So because of the current, voltage drop is like this. Now see one thing. Let's just call this as VL1 and this as VL2. What is the direction of VL1? This is your VL1. Okay. Let's just call this as VR. And let's just call this as VL2. Okay. This is what is happening in the circuit. At t equals to 0 plus L I naught upon L1 plus L2 current is flowing. Let's just call this current as I dash. Okay, because I don't want to repeat this expression again and again. I am calling this current as I dash. So I dash current is flowing through the L1 in this direction and it is giving it a drop of plus 2 minus. Now if you see from here, this is what this is grounded. From here this is grounded, like this is grounded. So from here if you go, this is a negative voltage drop and this is also a negative voltage drop, right? So basically your VL1 is negative of VR plus VL2 and your VL2 is positive of VR plus VL2. That means because of VR and VL2, the drop across the VL1 is becoming like this. Because of VR and VL2. Because of VR and VL2, across resistance, across inductance L1, we are having a drop in the negative direction. From here to here, from here to here. So this is the drop in the negative direction. That means the current will be decreasing. Are you getting my point? And because of VL1 and VR, we are having a drop in this direction for VL2. That means the current in VL2 will be decreasing as well. The current is flowing in this direction. Now it is giving the current in this direction. So basically the current will go to 0. Because of the opposite voltage drop, the current in both L1 and L2 will be decreasing and goes to 0 at steady state. Okay, or what you can think, or at steady state, you know one thing, VL2 and VL1 will be 0, right? Because this is what we mean by steady state. So this is a resistance R and both of them are 0, right? This is resistance R, both of them are 0. What is the drop here? 0 volt. So that shows that IL1 equals to IL2 equals to IR at steady state is 0 ampere. There are two methods I explained. First was very intuitive. We were actually seeing what is actually happening in the circuit. So what is actually at t equals to 0 plus, since the current is in this direction, that means the drop has to be like this and like this. Okay, from minus to plus. But because of the voltage drop of these two, there is a opposite voltage drop. Right? There is a opposite voltage drop that is decreasing the current. So this Li naught, this I dash current is getting decreased to 0 and here in this direction there was the current, but the voltage drop was in this direction, so current was flowing in this direction. So it is also decreasing to 0. Are you getting my point or not? I hope you have understood what is happening in the circuit. Okay. So I hope I will be able to add just one more page. Yeah, I will be able to add just one more page because the maximum limit here is 50 pages only. So what about IL1? IL1 at t equals to 0 plus, it was changed to Li naught upon L1 plus L2 and at steady state all goes down to 0. IR at t equals to 0 plus, what is the direction of IR I have made in the problem itself? That is more important. IR is flowing in this direction, that is in the same of IL2. So I have to make IR direction. So in this problem, the direction of IR I have made like this, okay, IRT. So IRT equals to 0 is negative of this, because this is our circuit now. This is L1, this is L2, this is R, this is IL1, this is IL2, and this is IR. So IL1 is the negative of IR and is the negative of IL2, right? So this is what is happening, and eventually it goes to 0 ampere, right? What about IL2? IL2 at t equals to 0 plus becomes from 0 to suddenly it goes to some value, and then at infinity it becomes 0, right? So I will make the graphs for IL1. Okay, this was also negative. This is for IL1. This is for IR. This is also for IL2. So this is IL1. Okay, did I discuss the time constant? What is the time constant here? Tell me. Time constant. L1 and L2 are in series because both of them will be having the same current. So both are in series. So L by R, L1 plus L2 by R. This is the time constant, right? Yeah, so initially it was I naught, then suddenly it decays to this value and then decays down to 0. Okay, so and in this case initially the current is 0, then it rises to this negative value, then decays down to 0. In case of IL2, actually IL2 and IR will be the same, both are the same only, no difference. Zero, then some negative value, then decays down to in the previous graph, and I made it, yeah. Okay, IR is 0. Yeah, okay, fine. Yeah, so this is what is happening in all these circuits. Okay, you can write down the expression as well. IL1, for IL1, how will you write? IL1T. How will you write? For T minus, it is I naught U of T minus. Okay, and for T plus, it is decaying. So L1 I naught upon L1 plus L2 e to the power minus T upon 2 UT. Right? Now, how about IL2? IL2 minus L I naught L1 I naught upon L1 plus L2 e to the power minus T upon tau ut. What about IRT? It will be the same, minus L1 I naught upon L1 plus L2 e to the power minus T upon tau ut. Right? Well and good. Let's move on to the next problem. So I hope you have understood all these three problems. I will just quickly revise it. What did we do here? In the first problem, I naught here, 0 here. They have to instantaneously change, and that would be the steady state because there is no resistance. Time constant is also 0, so that would be the steady state. In the second problem, I naught here, 0 here, but I naught has the path to flow through the resistance R. Now what will happen? In L1, the current will start decreasing, and in L2, the current will start increasing because of the voltage drop. So here it is increasing, here it is decreasing. So at some time, both of the current will be equal. The expression of the current, that would be L1 I naught upon L1 plus L2. In the third circuit, what is happening? 0 I naught here and 0 here, but there is no other path, so they have to change instantaneously. Now they have changed to change instantaneously, but because of the opposite voltage in both of the inductance, the current will decrease and go down to 0. Or you can think at steady state, both of the inductor will be having 0 voltage. That means there will be 0 voltage drop across the resistance. If there is 0 voltage drop across the resistance, that means there is 0 current flowing in the resistance R. And if 0 current is flowing, that yeah, you can think like that. 0 current is flowing in the resistance R. So that means in L1 and L2 as well, there will be 0 current. So at steady state, there will be 0 current in L1 and L2. Are you getting my point? Now in this case, what if I say that L1 and L2 will be shorted at steady state? Okay, that is fine. L1 and L2 is shorted at steady state. That means there will be 0 voltage drop across the resistance. That means there will be 0 current in resistance R. Are you getting my point? I am saying that at steady state, this will be my circuit. So that means 0 voltage here. So that means 0 ampere current is there, and that is fine. But you can't guarantee what will be the current here. You can't guarantee that there will be 0 current in these paths. Are you getting here? What is happening at steady state? Both of the inductors are shorted. Okay, so 0 voltage drop here. That means 0 current here. And if 0 current is there, so all are connected in series. So here as well there will be 0 ampere current. So this is fine. Okay, but here what you can say, voltage drop will certainly be 0 volt. That's for fine. VL, that's for sure. VL2 equals to VL1 will be equals to 0 volt. That's for sure. But for current you can't comment because here there is 0 ampere current. That means there can be some current in this direction as well, like this, or some current like this. Because 0 current is flowing, but some amount of current is flowing in the complete circuit, and this is what is happening in this circuit. There is some amount of current flowing in the complete circuit, and that is L1 I naught upon L1 plus L2. I hope everything is crystal clear to you, right? So this is about the complete three circuit and good analysis. Let's move on to the, and certainly it will be asked in GATE. In 2 to 3 years, these kind of problems are going to be asked, and what they will do, they will not expect you to go by Laplace transform, because if you go by Laplace transform, there is high chances that you will be doing some calculation mistake, the way I did here. Okay, so if you are comfortable with, for first time if you are studying, then it may seem that, oh, it is something very heavy, but slowly, gradually it will come to you. Okay, it will be all easy, right? Gradually, but it will happen gradually, right? So I guess I need to put a charger. So in meantime, you try solving this problem. This will be completed in this page only, which is very easy. Okay, so try solving it. So this is an RL circuit given to you, and there is the current source. You have to draw the V naught waveform. So what is V naught T? What is V naught T here? V naught T is L dit by dt, right? Simply this is, since the current is constant, now simply integrate this, differentiate this and multiply it with this inductance. That will be your V naught. So what will be your V naught? What is the integration of this? This will be your V naught T. What says T? Tell me what will be the integration? Simply an impulses, right? Initially I will be having an impulse here. Here I will be having an impulse. at t equals to 0 of Li naught, right, of Li naught at t equals to 0. How an impulse? What is the differentiation of step? That is impulse. And also you can think L, current is changing from 0 to I naught in no time, Li naught delta t, right, Li naught delta t, but we only show the area. So this is what I am saying. Now the current is not changing, I naught is constant. What is the differentiation of I naught? What is the differentiation of a constant value? That is 0. That means 0. Now at t by 2, what will happen? At t by 2, the current is changing from I naught to 0. So what is the change? I naught to 0 in no time. Okay, I think I can write it clearly as well. The current is changing from 0 to I naught in no time. So L I naught delta t, t equals to 0. Now the current is changing from I naught to 0. So final value is 0, initial value is I naught in no time. So that is minus L I naught delta t minus t by 2 at t equals to t by 2, right? So a negative impulse will be there. That is minus Li naught. Then again 0. Then same thing is happening at t, a positive impulse. So there will be these impulses. Okay. Simply any kind of input they can apply, and they can ask you what will be the voltage across the inductor. So what you need to do, you can simply tell them the differentiation, nothing else. They are just asking the differentiation, right? So only the differentiation will be there. That's it. Right? And it will keep on going. The magnitude will be Li naught only. Not the magnitude, actually the area. This will be the voltage. Are you getting my point? So basically your V naught T is Li naught and minus Li naught. For T equals to, what can I say, Nt. And here it is for T equals to 2n plus 1 T by 2. N value is from 0, 1, 2 and so on. Right? This is your V naught T. Li naught delta T. Sorry. Li naught delta T. I like, this is not how I should express it, because this is an impulse. So I can express it in better way. On the next page I will be writing it. Okay. So this will be my V naught T. It will be Li naught delta T, T minus Nt, right? And it would be Li naught delta T minus 2n plus 1 T by 2. Now n value is from 0 to 1, 2, 3 and so on. So does this seem fine? Li naught delta T, then at n equals to 1 Li naught T minus Li naught delta T minus T, then at 2 Li naught delta T minus 2T. Okay. And here Li naught T minus, at t equals to 0 it is T by 2 minus sign, and at t equals to 1 it is for 3T by 2. Yeah, this seems fine, right? So this is the correct expression of V naught T. Are you just getting the point? Simply the differentiation, nothing else. Okay. Now the next problem, simple RC circuit is there. I need you to find the value of V naught. Note the value of V naught, write the expression for V naught, or just draw the graph. Okay, draw the graph for V naught. Draw the graph for V naught. I am changing the question. Draw the graph for V naught. Okay, do it on your own, then only you should see the solution. Draw the graph for V naught. So tell me at t equals to 0, what is happening? This will be shorted, this will be shorted. Is there any infinite current in the capacitor? Is there any infinite current? No. Is there any ambiguity? No. Everything is fine. No ambiguity, no infinite current. So V naught at t equals to 0 plus is 0. At infinity, this is open ended. This is R2. This will be open ended as well. Right? And here I have 5 volt. Any ambiguity? If this is 0, this will be 5. You can define the potential of this. Yeah, I can define the potential of this because here there is 0 current. So this is giving me 0 voltage drop. So this will be 0 only. This will be 0 and this will also be 0. There is no ambiguity, right? You can't say this is open-ended. This is not open-ended because in the resistance R2 the current is 0, that you know. In resistance R2 the current is 0. So this will give me 0 voltage drop. So from 0 we will come here 0. So this is also 0, this is also 0. Are you getting my point? So V naught at t equals to infinity as well, it is 0 volt. In both of the case there is no ambiguity, there is no case of infinite current, it is simple RC circuit. So you are getting V naught at t equals to 0, V naught at t equals to 0 also 0 and at t equals to infinity also 0. So 0 here and at infinity as well it is 0. So will the graph go like this? Simply a straight line? No. Why so? Because this is not a first order circuit. Not a first order circuit. I mean these values are fine. If they are asking what is the value at t equals to 0 and what is the value of t equals to infinity, these values are fine, but you cannot apply. But you can't apply what? You can't apply this formula V of not, but I should write you cannot apply V naught of 0, V naught of infinity e to the power minus t upon tau, because applicable, this is applicable only for first order circuit. Okay. Now how will you solve this circuit? No one will ask you. Okay. In the exam, if they will ask you, they will just ask you these problems. And in the interview, if they are asking, they just expect you that you don't make the graph like this. You tell them this is a second order circuit, so I can't make the graph like this. Okay. Why it is second order circuit? Yeah, that also we need to see. Why it is second order. Okay, what is the order of the circuit? I will just find. I'm not telling this is second order. Order. What is the order? What is the order of the circuit? C1 R. This is R2. This is C2. Can you make both of the capacitor as one capacitor? C1, C2 are in series, C1, C2 are in parallel. If the case was like this, I could say C1, C2 are in parallel. Now one end of C2 is connected to node A, but the one end of C2 is connected to node A, other end of C2 is connected to node B, but the one end of C1 is connected to node A, but the other end is connected to some node C. C1, C2 are neither in series, neither in parallel. So there are two storing element, two effective storing element. Two effective storing element. So this is what? This is second order circuit. Okay, this is what? This is a second order circuit. Are you getting my point? So this is a second order circuit, and you cannot apply the exponential form here. Okay, so how will the graph actually go? Initial and final condition, does it depend on the order of the circuit? Does it depend on the input of the circuit? No. Initial and final condition, initial and final condition doesn't depend on the order of the circuit. It may depend on the input of the circuit. Okay, it may depend on the input of the circuit for sure, because in case of pulse input something different will be there. In case of step input something different will be there. But initial and final condition doesn't depend on the order of the circuit. Order of the circuit. Okay, even if it is second order, even if it is first order, so the value that you found, that V naught at t equals to 0 plus is 0 volt, and V naught at t equals to infinity is at 0 volt. Both are fine. Okay, both are correct. So we will start from 0 volt and we will come down to 0 volt only. Okay, this is V naught t. We will start from 0 volt and we will come down to 0 volt, and the graph will go something like this. Okay, so the graph will go something like this. Now this requires a much deeper analysis to understand why the graph goes like this, and it is neither important for placements, neither it is important for gate exam. Okay, if you want to know how it goes like this, I will add up a video, or what you can do, you can find the Laplace transform. You can solve this circuit by Laplace transform. You can find V naught s by V in s, and then you can solve the circuit. You will get a graph like this, or you can plot it in MATLAB. When I first did it, I plotted it in MATLAB to verify my circuit. So this graph goes like this. So it requires a deep understanding why it goes like this. So I will also add a video. I will also add a time domain video. You can solve the circuit by time domain as well, and that would be very, very deeper analysis, and like you guys will start getting confused. So the next video will be next video will be there, based on this. Okay, the analysis of this circuit in time domain. In frequency domain as well I will add the video. In frequency domain as well you will understand the time domain, you will understand the waveform, but that's very deeper analysis, and even if you have enough time, you have a lot of time, then only you should study that. And for gate aspirant I will not add that video, because for them it is not anyhow helpful. They will never ask it in the exam. It will never be helpful for you. Okay, so there is no point of adding that video. For gate aspirant I will not add that video. Also, like understanding the second order circuit, you will understand this circuit in control systems. You will understand this second order circuit in control systems. Okay, one complete chapter will be there, time response. Okay, so there we will deal second order circuit only, so that you will study in control systems as well. A much deeper analysis of second order circuit. What is overdamped system, what is underdamped system, what is critical damped system. Although basics of all those things I will be explaining in RLC circuits, but here I am not explaining. Okay, so what is the damping, what kind of damping is there, so these basics I am not explaining it here. Okay, and neither you need to understand this. When we study control system, a bit of basic idea you will get there. Okay, so the graph will go something like this, and I can explain one thing. It goes like this. Why doesn't it go in the negative direction? It could have gone like it could have gone like this, right? From 0 to 0. Why doesn't it go in negative direction? Because you know the voltage across C2 can never be negative. This 5 volt will charge the capacitor. So eventually it will be going up only, right? This 5 volt will charge the capacitor C2. So eventually it will be going up only. So the graph will never go into negative. So the graph will go something like this. So in the interview, if interviewer asks this question, he will expect that you don't say that it will be going from 0 to 0 in a straight line. You will say that it is a second order circuit, so it can't go like this. And the second thing is that Vc2 will be charged only. So it will be charged like this. It can never go to negative. Okay. So that's it. So that's the complete analysis you require for this circuit. Are you getting my point? Okay. And there is much deeper analysis, much deeper things are there. So that I will add for placement guys. If they have enough time, they can watch this video. If they don't have that much of time, they can simply skip those. Okay. Yeah. And if you have any further doubt, we will be clearing that in the doubt session. Okay. So yeah. And here we found the order of the circuit. So there is more method of finding the order of the circuit. So that we will be seeing in the next video, I guess. Yeah, this transfer function and what is transfer function. So basics of control system we will see here. So we will be making a connection between control system and network analysis now. Okay, certainly a bit of connection, not the complete connection. So once you are done with the control system and analog electronics, you will be able to correlate all these three subjects: network analysis, control system, and analog electronics. All these are correlated. You will understand that whatever we study in control system, that is just the S domain of network elements. Okay. So once you are done with all these three subjects, then you can only correlate. In one chapter only or in one subject only, I can't teach all the subjects. So whatever that is necessary for network analysis from control system, that I am adding up here. Okay. So in the next video, we will see what is transfer function, what are poles and zeros. From poles and zero, how you can find the time constant, and how do you define the order of the circuit from poles and zeros. Okay. And then we will see one simple example, two examples where you find the complete, when you find these three things basically: location of pole and zero, time constant, and the order of the circuit. Okay. And then we will see one more analysis. So this will be the next video, and after that we will be solving the assignment. Okay. And if you are enjoying the lectures, please do share it with your friends. Okay. Thank you.